Okay, let's get into the programming part now, and let us understand the code which is available. So we have NumPy, SciPy, Pandas, scikit-learn or sklearn. We have stats models. We have matplotlib, Seaborn, TensorFlow, Keras, PyTorch. And when it comes to natural language processing, we have NLTK, TextBlob, Jensen, regular expressions, Spacey, etc. Right? Always you need to remember, of course, you have word cloud and things of that kind. So always remember the at least library names which are used in the space of data science. What do we use for network analytics? Right? What do we use for text mining and NLP? What do we use for our other supervised and unsupervised algorithms? Yeah, it always makes sense. What libraries do we use for data pre-processing? There's something called as feature engine. Okay, so now let's get to this. We have Pandas, NumPy, scikit-learn. From scikit-learn pre-processing, we are importing label encoder. And then we have the data here, credit.csv. Let me go to that data set. Let me copy that. So you have data in which you have 1000 rows and 17 columns. In this specific data set, given all the various inputs, we need to classify whether a specific customer would default on the loan, yes, or not default on the loan, no. Okay. This is the business problem. Is this classification problem or regression problem, friends? If you have output variable, which is discrete, and if it is categorical data, is this categorical data? Yes and no, or continuous data? Categorical data. So here, this is categorical data. When you have categorical data, okay, how many classes do we have here? 2 classes. Then it's called as a 2-class classification problem. It's called as classification problem. If you have a number, numeric value that you're trying to predict, then it's called as regression problem. If it is categorical data, it's called as classification problem. So what problem are we trying to solve here? Classification problem. Here we use inputs. Okay. Do we have any null values? Go to the data. Is there any null value? If yes, show me the summation of that. Do we have any missing values? Not really. So you need not worry. Absolutely. If you have any values, for example, NA values or null values, etc., when you say drop NA, it's going to remove all of your NA values, but we do not have any, so we need not worry much. When I say data.columns, it will show you what are the various columns available. When I say data.info, it's going to give you more information about your data set. It's saying that you have 1000 entries. Entries are nothing but rows. You have 1000 rows. And saying that index values are from 0 to 999. Obviously, indexing in Python starts from 0. And you have total how many columns? 17 columns. So all the columns, right? And you do not have any null values. Non-null values are 1000. Out of 1000, 1000 are non-null, not null. Meaning how many null values will be there? 0. And for each and every variable, is it categorical data or is it numeric data is provided. Categorical data in Python is called as object. Categorical data in Python is called as object. For example, checking balance, less than or equal to this is one class or one category. 1 to 200 is another class. Unknown is another class, right? In that way, you have multiple classes. So it is showing up as object. Here, months, loan duration, these are all numbers. And these numbers do not have a decimal value, hence they are called as integers. If any of these numbers have decimal values, then they'll be called as float. Absolutely. Okay. If you feel that, you know what, phone, whether that is what your common sense says. That is what your domain knowledge says. Then what do? You just remove that. You say data or drop this phone. Axis equal to 1 means column. Axis equal to 0 means 1 means column. Go to this column called phone, drop it. So if I drop this one column, how many columns will I have now? From 17, it will become 16. Run it, and there we have 16 columns. And you're saying data or describe. If you just run that, you'd get the description on what is each and every column. What is, how many values do we have? What is the mean, standard deviation, minimum value, max value, 25th percentile, 75th percentile, and 50th percentile. But if you want to store that in another object or variable, sure, you can do that. When you say equal to, it will get stored. For every column, you have the details. Here I have 16 columns here, but it's showing only 7 columns and 8 different values like count, mean, standard deviation. All these are 8. This I understand, 8. But then why only 7 out of 16? Numeric, okay, absolutely, you're right. Only for integer or float, that is only for numeric values, you can calculate mean or standard deviation or minimum or max or any of the percentiles, right? So how many numeric values are there out of 16? 7. For all of those, you get these. Good. Okay. But then when you work on your assignments, you have to explain on what does this mean? Mean 20.9, so what? Standard deviation is 12.05, so what? You need to answer this question on so what. Okay, please remember that. Try to think through and then answer, okay, I believe that the standard deviation is 12.05. That means the variance is high, variation is high, or variation is low. Uncertainty in the data is less. So I foresee that the final result will be better. In that way, you have to. And wherever you have categorical data, you can also perform label encoding. Label encoding means you're just trying to convert the categorical data into some numbers. Should I always do it? Not needed. If I open and close the braces, label encoder, and if I do not mention anything within that, what hyperparameters will it choose? What options will it choose when I just open and close the brackets? It will choose all the options. Okay, within this, whatever are the various options available, it will choose all of that. And what are the default values which it is going to use? It is going to use the default values which are available. Friends, come on, this is a little, okay, anyways. So whenever you have any function, within that function, you will have hyperparameters like this, which are options. If I do not give anything within that, it will take all the hyperparameters available in that. And the default values assigned to that will be taken. But if you feel I don't want default values, I'm going to supply some value, then supply it like this. Criterion equal to entropy, supply in that way. Then the algorithm will understand that, hey, this person is saying that don't choose your default criterion value, choose entropy, is what it understands. If I say help of dt, it will give me list of all the hyperparameters which are available. In that way, for every function within Python, you will have list of hyperparameters. Okay, which are options, which can be changed and experimented. What happened? We have run these many algorithms and still you're like, what is he talking? I each time repeated this. Each time I repeated this. I don't mind repeating again whenever that appears, but each time you sleeping is not done. Okay. So number of features, number of outputs. Okay, so there are many other options. So maximum, how many features do I need to use? What is a random state? What is the maximum number of features, right? What is a random state value? All these are called as what? Minimum impurity decrease, maximum leaf nodes. What are all these called as? Hyperparameters. Okay. Every function will have such set of hyperparameters. And every hyperparameter will have a default value. Default value. Right? Everything will have a default value. Okay. So if I open and close the brackets, and if I do not mention anything in that, then what will it choose? All the hyperparameters pertaining to this function. And all the default values will be taken. If you want to know on what are the various hyperparameters, what should you do? Help of, okay, whatever is given here, type that. Okay. And when you run this, it is going to give you list of all the hyperparameters which are available within this function. Okay. These are examples, etc., which are available. Yeah. You can. If it is discrete or if it is numeric, if you feel that I want to create buckets, do so. If it is this. But if your common sense says that, no, I want these to be not converted into discrete variable, but these are count like 6 months, 48 months, 12 months, let it be as is. If that is what your logic says, let it remain as is. There is no hard rule that if you see numbers discretize. That is not what I'm saying. Based on whether it is really applicable there or not, you decide. Nothing of that. There's nothing of that. But the only thing is, if you have an algorithm which behind the scenes does some multiplication, addition, subtraction, deletion, square root, and all that, then obviously you need numbers. So given your data, you convert it into numbers. Sometimes your algorithm itself will tell you that it will throw an error message saying that this data cannot be processed because you need to convert that into numbers, numeric, and convert it. Certain times algorithm itself will convert to numbers. Either it will do one-hot encoding or label encoding. In some fashion, it will only convert. Okay. Both. All the techniques on the planet, I repeat, all the techniques on the planet, except for regression techniques, can be used both when your output variable is continuous or numeric, and it can also be used for output variable which is discrete, categorical. So we need not worry whether output variable is numeric or non-numeric. We need not worry. Job done. That's it. Simple. When we get into regression techniques, then we'll understand that when output variable is discrete, categorical, in two categories, then you use logistic regression. If the output variable is numeric, then you use linear regression. That classification comes there. Apart from that, every algorithm can be used for every purpose. Okay. Certain algorithms, if you supply numeric data, it would convert that numeric data into categorical. Okay, it will automatically do the discretization. One such algorithm is your decision tree algorithm. Okay, so here what we are doing is we are taking each and every categorical variable like checking balance, credit history, all these are categorical variables. We are performing label encoding. Should I do it? Not needed. Why are we doing it? Just because one additional option will be explained to you guys. That's it. There are many options, right? In every algorithm, we put certain options. We're putting some options. Okay. So where is data here? If you see, we converted everything into numbers. Okay. If it is integers or float, it would convert and do the analysis. But if it is object, then it will not. Object means what is object? Categorical. If I tell male and female, 0 is male, 1 is female, will that be numbers? Or numbers or object only? Just because you put 0 and 1 doesn't mean it will start treating that as integer. Right? It is still categorical data only. Just that you convert it into numbers. Making sense? Okay. Where we have Madhuri, I could not find it. If you found it, wonderful. Let me know, please. Yeah, Madhuri. In which column? I wish to open that column and then check. Where do you have missing values or unknown values? Yeah.
In checking balance,
Okay, I'll go here. Unknown is one category. Unknown is one category within this.
Okay, and also in saving balance. Okay.
Okay. That is one category, Madhuri. It's not missing value.
Okay.
Okay.
Fine.
If it is a missing value, what you should have done is converted. You should have written a code wherein that unknown value would get replaced into NA value or NAN value, and then you drop it or input it, right?
Yes.
Yeah. Okay. So if you go to data, default is one column here. Default is one column here, and default has entries such as no and yes. And the data type is object. Value count. No has 700 entries, yes has 300 entries. Do you think it is balanced data set or imbalanced data set? Okay, maybe balanced, maybe imbalanced because it's just on the wall. All right. But less than 30, it's just one number. I mean, if I would have had one number less in this, then that would have been called as imbalanced, right? Going by our rule. So we can also treat this as imbalanced. but we will see how to deal with balance versus imbalance. All right, now list of, I'm taking all the columns, I'm converting all the column names as list, and here are all the column names. Out of all these columns, the first 15, which is from 0 until 14 are inputs. The last one, which is 15, is a target variable, output. Will a person default or not? So I'm just segregating. I'm saying right from the beginning until this 15, all these column names will be part of predictors, and the last column would be a target variable. Then we are saying go to scikit-learn model selection. From that input, train, test, split. And then we are saying train, test, split. Take the data, and I want 30% of data to be in test data, and another 70% I want that to be part of my training data. In this train, test, split, what kind of split happens? Random split or sequential split? Random split. Always it is random split. That means I will have different data in training and I'll have different data in test. That also means that each time I run the algorithm, I'll keep getting different accuracy values, right? Because each time I split into training and test, I get different data into training, I get different data into test. When I build my model on training and test it on test, I might get different accuracies each time because the data will be different. Is the accuracy values fluctuating a lot? Each time I split the data, train on the training and test on test, would the accuracy values fluctuate a lot? Or would the accuracy values be close? Is something that you have to look at. If the accuracy values are fluctuating a lot, then you have to run this algorithm multiple times. And each time you run, it's going to split. And you'll be training on different data sets, testing on different data sets, because it's a random split. Do it at 10 times. For all the 10 times, take an average. That you will say would be my final result. And that's called as bagging. That is called as bagging in Ensemble techniques. We'll get there. Okay. So from scikit-learn, we import decision tree. Here we are using criterion as entropy. And then we're going to fit the model. When we fit the model, we are using predictors, which are nothing but inputs, and the output is target, and we run it. Okay. Once you build your model, what do we do with that model? We take that model and we predict on the test data. So we have data, which is split into training and test. And we already segregated the data into predictors and targets. Predictors are nothing but your inputs. And then you have your target, which is your output variable. So we have our inputs and outputs. Then when we are training, we are training it on inputs and output. We build the model. We take that model and we are trying to predict on the test data inputs, which are nothing but predictors. When you do that, you get predicted values. Now you are saying, let me go to test data target, which is the actual value, and let me compare it with the predicted values. Let the row names be actual values, column names be the predicted values. And create the crosstab. So 168 entries, which are actually no, have been predicted as no. 38 entries, which are actually yes, have been predicted as yes. So this diagonal would be giving you the right prediction results. 51 entries, which are actually no, are classified as yes, incorrect. 43 entries, which are actually no, are classified as no, incorrect entries, right? So the correct classification is 168 plus 38 divided by the overall count. What would that give you? Accuracy. Either do that manual calculation or do this. Predicted values, compare, double equal to means comparison operator. Compare it with the actual values. And if it is same, the result will be true. If they're not same, result will be false. How many times is it true? 0.686. So 66 is the accuracy. Now, whenever we build the model, what should we also do? We should, after you build the model, we predict it on the test data, but we also have to predict on the training data, right? So that is what we are doing. Take the model, predict on the training data. Predictors means inputs. Then you get the predicted values. Training data will have the actual values in target. So take that actual, compare it with the predicted values. Row names should be actual, column names should be predicted. So let me run it. Wow. Are there any misclassified entries? No. When you look at, or when you compare the predicted values with actual values, double equal to means comparison operator. If they are the same, you'll get true. If they are not same, you'll get false. On an average, how many times you have true? Oh, 100%. Training accuracy is 100%. Test accuracy is 0.68. So what is happening? Overfitting. Overfitting means training accuracy will be high, test accuracy will be low. When your model overfits, what should we do? Apply regularization techniques. Yes. Here, either, say that minimum sample leaves equal to 1, run one algorithm. Minimum sample leaves equal to 5, run another algorithm. Minimum sample leaves equal to 10, run another algorithm. Minimum sample leaf equal to 20, run another algorithm. Save all the 5 model accuracies, training and test accuracies. Then experiment with maximum depth equal to 2, maximum depth equal to 4, maximum depth equal to 6, 8, 10. Another 5 experiments. Take the training, accuracy, test accuracy. Then try out with maximum features equal to square root. Then do this. If you keep doing this, there can be hundreds and thousands of experiments which you can perform. It is time consuming. Hence, we have something called as grid search cross validation. Grid search cross validation. And when it comes to decision tree, okay, here we have all the, I'm not sure why they're writing it as parameters. According to me, it's incorrect. But anyways, since they are writing it in this way, let's focus on this. These are all actually called as hyperparameter strings because you can try it with these 2 options. Splitter, you have 2 options. Maximum depth, you have different options that you can provide. So what this grid search cross validation will help you do is, it will help you experiment all of these things at one go. You define all of your hyperparameters and say that minimum sample leaves, maximum depth, maximum features, and criterion is entropy. Now, when you run your grid search cross validation, you say, I want this decision tree model to be run. When it comes to parameters, I want to use all of these parameters. I want accuracy as a measure to be used. I want to calculate accuracy at the end. Number of jobs equal to -1 means I want to use all the processes. You know what? We will have dual core processes. Means what? There'll be 2 processes, processor 1 and processor 2. Quad core means you'll have 4 processes, processor 1, 2, 3, 4. When you try to use all the processes at one go, it's called as multiprocessor, right? Serial processing, parallel processing, etc. Okay. So when you try to use multiple processes, it's called as multiple processor processing, or it is called as parallel processing. So you have all these experiments to be performed, right? Each experiment will be run on one of the processes in parallel. Not one experiment after another. All the experiments. So if you have, say, 16 experiments as an example, 4 will run here in this, 4 will run in this, 4 will run in this, 4 will run in this. So everything will get completed at one go. If you have serial processing one after another, it will take huge amount of time. If you say -1, you're saying use all the processes that we have. Then we have cross validation equal to 5. We have refit equal to true, return train score equal to true. Okay, let me explain here about cross validation. The other two, some other time. So cross validation equal to 5. What happens here? Let me explain. This is also a technique which is used to handle your class imbalance. Suppose you have a data set which has 10,000 observations. Okay. Suppose you have 10,000 observations. If you say, I want to do a k-fold cross validation in which I want to define the k value as 5. Then what happens is this entire data set will get split into 5 parts. Observation 1 until 2000 would be one part, part 1. 2001 until 4000 will be part 2. 4001 until 6000 will be part 3. 6001 until 8000 would be part 4. And 8001 until 10,000 would be part 5. So you have 5 parts, 1, 2, 3. And it will also have 5 folds. Fold 1, fold 2, fold 3, fold 4, and fold 5. If you have class imbalance, that means one of the classes will be less. Correct? Default, not default. When I say we have an imbalanced data set, then the default cases will be less. So your model will be learning less default cases. It's like you preparing for exam. If I give you only 5 questions from probability, all the remaining questions are from machine learning algorithms. That means you'll be learning less on probability because there are only 5 questions for you to prepare. The remaining all you'll be preparing on machine learning algorithms. So the learning will be more on machine learning algorithms. It will be less on probability. This is also seen. If you have less default cases, you'll be learning less of default, examples. So here what happens is in fold 1, out of these 5 parts, your model will be trained on part 2, part 3, part 4, and part 5. On these training happens. And when you test your model, you test it on part 1. For this part 1, you get the predicted values, actual values, compare, you get error, all that. Then in fold 2, you train your model on part 1, part 2, part 3, part 4, and part 5. And then you test it on part 2. In fold 3, you train your model on all the parts except for part 3 because you test on that. For fold 4, you train on all the parts and test it on part 2. And fold 5, you train it on all the parts and test it on part 5. So in some sense, you're training your data on all the parts and you're testing your data on all the parts. Okay, so that every observation, whether it is used more times or less times, gets equal opportunity to be tested. Gets equal opportunity to be trained. Okay, so this is a technique which is used to handle imbalanced data set. And when I say cross validation equal to 5, that is exactly what is happening. Okay, you can always go to, this, you can always say help of grid search otherwise. List, I'm not sure. Let me see. Yeah. Okay, you have all these hyperparameters which will get generated. In this, you have refit. Okay. All these are the hyperparameters. For whichever hyperparameter you're giving the information, it will take only that. For remaining hyperparameters, it will use its own. Okay, here is refit. Refit an estimator using the best found parameters on the whole dataset. So what you're saying is train the model on all these different set of hyperparameters combinations, and then choose which combination is giving you the best result. Once you figure out those best found hyperparameters, train your model using those best parameters on the entire dataset. Okay, that is what we are seeing. Then return train score equal to 2. Number of jobs, you read that I already explained here. Cross-validation we discussed. So a few hyperparameters here, there we will try to understand. Friends, by default, it is false. Okay, false means the cross-validation results when you use this attribute. When you use this, all the results, cross-validation results will show up. But if false, this attribute will not include the training scores, because when you're building a model, you split the data into training and test, build your model on training, test on test. You get the test results. But you also should fit your model on the training data and then get the training accuracies, right? So by default, those training accuracy values won't be stored. But if you say return underscore train underscore score equal to true, the training scores also will be stored. And what scores you want? Accuracy values. Each time you're given an option, go like this. Okay. Try to see, explore. You might have questions such as, okay, what are the other scoring methods which are available? Okay, scoring. So all the details are available here. Just strategy to evaluate the performance of cross-validation, right? And you'll have the different details here. And when you scroll down, you'll have the other details also pertaining to scoring. It's not just accuracy. You can also have mean squared error, negative mean squared error, so on and so forth. You can go through that. You'll find it. Okay. So we are taking these, whatever hyperparameters are mentioned within these brackets, and whatever values you are mentioning, those values will be chosen for these hyperparameters. Whatever are the other hyperparameters which are not listing here, all those will also be selected, but the default values of those will be selected. Now, when you want to fit your model, obviously you need training data inputs and training data output. So you train your model. It's taking a while, the red symbol here. The reason being all these experiments should be performed. And then when you use this attribute, this is called as attribute, then it will show you on what are the bunch of best hyperparameters. So it's giving for depth equal to 4, maximum features equal to square root, minimum samples leaf equal to 20. For this, it is giving you the best result. Best accuracy is obtained for this. Okay. So you're saying take the best estimator, means the best model, store it in this. Then go import from scikit-learn metrics, accuracy score and confusion matrix. Then compare the test data actual values and use this best model out of all the combinations out of all the combinations, you pick the best model here. Use that and predict on the test data. When you predict, you're using the best model, friends, and storing it here. And you're saying, let me use this best model and predict on the test data. What would you get? Predicted values. Then you're trying to compare it with the actual values. Here also you're doing the same thing. Predict using the best model on the test data inputs. You get the predicted values. Compare it with the actual values. You get the accuracy score. Okay, so you have the accuracy. Okay, this plus this divided by overall, it is 0.74. But this is what accuracy, test accuracy. Now we also have to calculate for training, right? So I'm saying use the best model, predict on the training data inputs, you get predicted values, compare it with the actual values. You get the confusion matrix. This diagonal, which is 4, 32, and 74 are the correct predictions. Off diagonal are incorrect predictions. And here the accuracy is 0.72. Is the training accuracy and test accuracy close to each other? Yes, that's called as a right fit model. Okay, now there is also something called as randomized search. And one is grid search. In grid search, what your model will do is it will try out all the combinations. Minimum samples 1, maximum depth 2, square root. 1, 4 square root, 1, 6 square root, 1, 8 square root, 1, 10 square root. Then 5, 2 square root, 5, 4 square root, 5, 6, 5, 8, 5, 10. Then 10, 2, 10, 4, 10, 6, 10, 8, 10, 10. Then 22, 24, right? 26, 28, 20, 10. It does all the experiments. It will not leave out even a single experiment, but that would be time consuming. Whereas in randomized search, it will randomly choose a few experiments and it will run. It will not run everything. So grid search will be time consuming because it will try out all the combinations and it will pick up the best results from that. Though it is time consuming, you'll get the best result. But randomized search, what will it do? It will randomly pick a few experiments and run it. So it'll be fast. It will be fast because it'll be only randomly choosing a few. But how about accuracy? Accuracy will be less. So you're saying, I want to generate a list of 1 until 50, all the values and do all those experiments for minimum samples. Maximum depth from 2 until 20, I want all the experiments and it has to be. So that's how you're defining your parameters and you want all these to be run for how many times? 50 times. Because each time you run, okay, I can also show you this. Would it show up here? Here it is, number. Number of parameter settings that are sampled. Okay, number of iteration traits of runtime versus quality of the solution. Default is 10. Okay, number of parameter settings that are sampled. Okay. So I think my explanation was wrong. I'll just take it back. So here what it does is out of all the combinations, all the various combinations, it's going to pick up how many combinations? 50 combinations randomly and it will run it. So we run the model. And once you run the model, what are we doing? We are not running the model. We are storing all these hyperparameters in this. Only when you say dot fit, it's going to run the model. And you want to fit it on inputs and output. Then you're saying, after the experiment is done, show me the best result. Where are you obtaining the best results? When minimum samples is 16, maximum features is square root, and maximum depth equal to 19. You're also saying, take the best estimator, best result model, store it in this, and use that model, best model, to predict on the test data. Then you get the predicted values. You're saying compare the actual values with the predicted values. Okay. This is one way of creating your confusion matrix. Then when you say how many times the predicted values are equal to actual values, on an average, you're getting 0.71. Then you're using your best model. You're saying, let me predict on the training data inputs as well. I get the predicted values here. Let me compare the actual values and predicted values. Row names and column names are given. Let me run it. This gives me cross table. Then if I compare the predicted and actual values, how many times on an average we have the good results? 73%. 73 and 71 are more or less close to each other. So you conclude that it's a right fit. Can I improve the accuracy? Sure, experiment. There are various other hyperparameters. Keep doing that. And at some point, you'll find that both your training and test accuracies are together increasing. Okay. All right. This is when your output variable is categorical. What if the output variable is numeric in nature? This is also a pretty straightforward code. So let me run this. Okay, whenever you're done, please remove, because it will free up your memory. Import all the required libraries. Code modularity is very important. Loading all the libraries, do it at one place. Then load the data set, do the pre-processing at one place. Then splitting the data at one place, then building the models at another place, testing your model. In that way, you differentiate the code. That's called as code modularity. Whenever you appear for interviews, in the first round, it will be verbal. Second round, they will give you a data set mostly. They'll ask you to write the code. They'll give you 24 hours, 48 hours. Right? When you write the code, they also look at whether you're writing comments for the lines of code or not. Point number one. Point number two, whether you're maintaining code modularity or not. Blocks of code. So please bear in mind that code modularity has to be included. You can, absolutely. So if your output variable is numeric, can I convert that output variable into categorical data? And then can I still apply decision tree classifier? Yes, you can. Absolutely, you can do it. So let me take this movies data set. Run it, reapply. So we have 18 columns, and you also have information on how many rows we have, how many columns we have. Do you have any missing values? No, there are no missing values. How many of these are float? How many of these are integers? How many of these are objects? How much memory is it consuming overall? All this information is obtained. Then you have df.head, which shows you the first 5 rows. Okay. And if you feel that there are certain variables and I want to create dummy variables, pd.getDummies from this df, I'm going to choose 2 columns. One is this 3D available. another is genre. These two seem to be non-numeric. So when I say drop first equal to true, what it does is it's going to take yes and no. Out of this yes and no, which one will be 0 and which one will be 1? No will be 0, yes will be 1. Alphabetically A, B, C, D, E, F, G, H, N will come first, then 1. 0 and 1. Whatever is 0, that will be dropped. Dropped first. Whatever comes first, drop it. That's the meaning of this. Okay. So if you look at this, you have 3D. In 3D, you have yes and a no. Out of that, this only yes is there. No is not there. So that's the meaning of drop first equal to true. All right. Now again, you can say info. You can see the data. And the 0, 1 are called as unsigned integers. There's no sign, plus, minus, nothing. Okay. Next, we are segregating all the inputs from outputs. So here in this data set, the business problem that we are trying to solve is, given the marketing expense, given the expense of production of the movie, right? Given the budget, multiplex coverage, so on and so forth, what will be the box office collection? How much money will the movie make? This collection is your output. So what we are saying is, take all the rows, take all the columns which are not equal to collection. Means except for collection, take all the other columns, put it in predictors. Take only collection and put it in target. Predictors are inputs, target is your output. We're just segregating these two. You can also check the type, which is not needed ideally. Says that it's a data frame. Now, what we are doing is we are splitting the data. We are importing train test split. And we're saying, let me split both inputs and output. 20% test, another 80% train. When you say random state equal to 0, what does it do? Each time you split the data, the same data will go into training and the same data will go into test. Okay, that's the application of this random state. Okay. Now we are importing tree. From tree, we are trying to import decision tree classifier, in which we are just giving maximum depth equal to 3. And we're saying, let me fit the model. Once you build your model on training, you need to predict your model on the test data. We're also predicting a model on the training data inputs. So you get test data and train data predicted values. And then here you're saying, let me import mean squared error and R squared value. Both of these we will learn later. What is mean squared error, R squared? Both of these we will learn later. Then you're saying mean squared error of test data, out actual values, and test data predicted values. You get the mean squared error. Then R squared value. R squared value ranges from 0 to 1. If it is closer to 1, it is better. That is all you need to understand at this point of time. Then you are also calculating the mean squared error by taking actual values and predicted values of training data. R squared value is 0.8. Train, test. There is a difference, 20% difference. So certainly what is happening? Is your model getting overfit or underfit? What is happening? Overfitting or underfitting? Overfitting. Training is more, test is less, overfitting. Since it is overfitting, let us try out another thing, which is pruning. Right? I would say minimum samples equal to 3, minimum sample split. That's the hyperparameter that we are using here. and I'm storing the hyperparameter in this, and I'm using that to fit the model. Once you fit the model, you're saying, let me use that model and predict on the test data inputs and training data inputs. So both test and train predicted values would be there. Then what am I doing? I'm saying, let me calculate mean squared error by giving the actual and predicted values. And also let me calculate R squared. Mean squared error doesn't make sense here, but anyways, I'll get it removed later. Then you're trying the same thing on your test on the training data as well. So you're getting 0.9 and 0.63. Is your model overfitting? Very clearly it is overfitting. Then if I say minimum samples underscore leaf equal to 3, then same thing. We are building the model. See, we are storing the hyperparameters in this. Dot fit means it will fit or train the model. And then dot predict means it's going to predict based on the train model. Then once again, you can calculate the mean squared error or R squared value. Oops. Here also it is overly overfitting. Since it is still overfitting, what are you expected to perform? You are expected to go to your grid search technique, use all these kind of combinations, and then experiment a few more options and see for what options your model is giving you good accuracy with respect to train and test, which are close to each other. Okay. What? Yeah. No problem. Sorry? Rule-based model. Oh yeah, you can see all the rules. Yeah, you can see all the rules. All the rules will come out. But if you have more inputs, it will have multiple branches. Taking each rule and then putting it in some code doesn't make sense. Ideally, what people do is they save the model in a format called as .pkl or .yaml, or there are different formats in which you can save your model, or JSON format, etc. Once you save the model in that format, you give that file to your web developer. Your web developer will put that in the code. And then what happens is whenever you have inputs, automatically predictions happen and results will be seen on your web application or mobile application. That is what. Yeah, correct. All the rules are there. You can also view all the rules, but it will just make the screen very clumsy. All the rules will be. You can see the tree also, root node, how it is splitting, all that visualizations. Exactly. Output. Exactly. Or simply put this function, dot predict, whichever is the best model, right, that you build will contain all the rules. This model that you build will contain all those rules. You just say dot predict and whatever is the new data, supply it here. No, it won't come up like that. So all rules are equally important. Yeah, all rules are equally important, but the variables that you use can be based on your information gain. You might want to shortlist only the most important rules, most important variables. You calculate information gain. Information gain can be calculated for all the variables. Out of that, you might say that, you know what, I want to take only the best 80% of the variables. And using those 80%, you build your decision tree. Every rule on a branch will have variables which will have same information. Root node, then the next. Okay, let me show you this. No, no. Rule will not have because, okay, here tell me, which rule do you think is important? But I also want to know rational. And why do you think certain rule is important? Yeah. This has the highest root, highest information gain. But this is highest information gain in every classification rule. Either pick up this classification rule, this is there, or pick up this is there. And in the next, you'll have the next best variable with the next best information gain. That would be there in this rule also. It be there in this rule also. You cannot say that this rule is important. How? The variables that you're using are the same. Here also you're using the same variables. Here also you're using the same variables. That means it is biased. You're saying that my rule should be biased towards these three. And this rule, I don't want it to work well. If this rule doesn't work well, you're saying your model is being biased towards credit rating. If credit rating is given, your model will give you less result. That is not how your model should work. It should be generalized. Your model should generically apply onto the future data by, saying that probably this rule should behave in a different manner, give me less accuracy as opposed to this rule. You're yourself saying that I didn't build a good model. My model won't generalize. My model is very biased, is what you're saying. That's not how it works. Your entire data is important. Yeah. 1,000 rows. It will fit. Yeah, it should. Oh, yeah. Some rule will be lengthy. A few rules will be shorter. Correct. Tell me out of the data set, entire data set, which data set will not contain the root node? Or which row doesn't contain the root node? Out of all the rows, which row doesn't contain the root node? I'll give you data set. Data set will contain multiple columns and 1,000 rows. Give me one row which will not contain this variable called student. Or name me one row which will not contain income. Every row will contain student. Every row will contain income. So every row will be involved. Okay, so we will take a break, and when we come back, we are going to talk about ensemble techniques. Okay, before that, what do you think is a disadvantage of decision tree? No, not really. Overfitting depends on your underlying data. A lot of iterations, okay. Each time I split the data into training and test randomly, will it give me the same result? No. Results will vary. Accuracy values will vary. Hence, let's look at how to fix that issue first using ensemble techniques. Okay, and then we'll proceed. Okay, let's take a break and come back. Okay, I think Madhuri has a question. Yeah, Madhuri.
So we are using pruning techniques and also the grid search CV and randomized search CV. All these techniques are used to overcome the overfitting, right?
Grid search cross validation and randomized search cross validation is only used to experiment with the hyperparameters, because manually giving all these options one after another and running would be time consuming, right? And the code also will have too many lines. Hence, we are using all the hyperparameter values and experimenting at one go. For that, you use grid search cross validation or randomized search cross validation. However, pruning techniques, pre-pruning or post-pruning, maximum depth or minimum sample leaves, so on and so forth, are your hyperparameters which are used to avoid overfitting.
So first we can do pruning techniques, and with the pruning techniques, if we overcome the overfitting, then we don't need to go for the grid search or randomized search because it is time consuming.
No, grid search and randomized search is used to experiment with the hyperparameters, Madhuri. Say your model is overfitting, what would you do?
We'll experiment with the hyperparameters. Yeah.
What are your hyperparameters?
Maximum depth, minimum sample split.
How many will you experiment? I will say maximum depth 2, run one algorithm. Maximum depth equal to 3, run one algorithm. Maximum depth equal to 3, run third algorithm. Maximum depth equal to 4, run another algorithm. Maximum depth equal to 5, run another algorithm. Are you saying I'm going to run this code? If I want you to run maximum depth from 1 to 50, are you going to run this line of code 50 times?
No.
Is that not a good? That's what you're saying. Let me do that. What I'm saying is maximum depth will help you avoid overfitting.
Yes, yes.
Instead of saying I'll run one like this, again I'm going to put piece of code here. Okay. This time I will say maximum depth equal to 4. Again I'll run it. Again I'm going to fit my model. Again I'm going to predict. I'm going to do all these things for all the options multiple times because you want to avoid overfitting, right?
Yes, yes.
But
Yes.
is this a wise decision or combining everything at one go and saying that from 2 to 20, experiment all the options at one go? Is this a good option?
Yeah, grid search CV is a good option.
Grid search or randomized search cross validation is only a mechanism to experiment with all your hyperparameters at one go.
And also we are finding the good model with the hyperparameter. Yeah. So here pruning is, I think it is not necessary every time, I think.
Maximum depth when I use this, is it not pruning the data set?
Yeah, it is pruning. It is pruning.
That's it.
Yes,
How are
yes.
you pruning? Manually, if you want to run one by one, do it. Or
Okay.
automate it. This grid
Yes.
search and cross randomized search is automating the process. Automatically, it's doing all these experiments for you.
Okay. Yes.
Mhm.
Thank you, sir.
Okay. Okay. Let's take a break, come back, and let's get into the much awaited set of algorithms. Okay.